All right, grade 8s, welcome to our lesson for the week. I won't be here on Monday, so I thought I'd pre-shoot this for you. So I really hope we can get it uploaded well so it works. Well, we're working on 5.2, calculating percents. Percents is one of those things that I find kids, they get it or they don't. Like, once you got it good. So really, while you're watching this video in class with your sub on Monday, what you should be doing is pausing the video now and then and posing some examples to each other. If you find a kid beside you really gets it, you want to work beside them, and I highly urge you to work on your assignment in partners. Anyhow, calculating percent. Going through some of the examples. It starts off by saying, work with a partner, copy this shape. Redraw the shape so each line segment is 150% of the length shown. So I'm just going to do this in dots on the board. I can see it's 1, 2, 3, 4, 5, 6 wide. So I'm just going to do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Because there was 2 rows of squares, and then 4 more beneath that. 1, 2, 3, 4. So if it's 6 wide, well, 6 wide, 150% of that is 9 wide. So what that would mean is if I had 1, 2, 3, 1, 2, 3. But now it says I should extend this so that each line segment is 150 of it shown. Each line segment, 1, 2, 3, 4, 5, 6. Each one is a line segment. So what I'm going to do is this. These lines are 2. Well, 2 times 150%, or 2 times 1.5 equals 3. So I've now extended each line segment to 150 what it was. It was 6, now it's 9. 6, 9, 2, 3, 2, 3, 2, 3, 2, 3. And that's what I would get. So all we're doing is we're taking each number and then we're timesing it by 1.5, or 150%. And we'll get into more examples. So right now, if you're nodding your head going, yeah, I get it, you're probably going to get all this right away. If you don't know it yet, don't worry, we've got more examples. So let's take a look. It says, recall that when the whole is 1, you know that 100% equals 1. Well, that's true. 100% is equal to 1.0. If I have 1 of something, I have 100% of it. If I ate 1.0 cakes, I ate 100% of those cakes. So 10%, well, a 10% would be a tenth of that. 0.1, 1/10, 10%. And then 1% would be 100th, because 1% is 100th, or 0.01. 1 in the hundredths place is 100th. We can extend the pattern to write percents less than 1% as decimals. So it says extend the pattern. This is the pattern that we're seeing. I looked at this initially and thought, well, what pattern do you mean? It means this. The pattern is the decimal is going 1, 2 places to the right. So 100%, don't is 1.00, or 1.0. 10%, 1, 2 decimal places is 0.1. 1%, 2 decimal places, 0.01. So if we're going to extend that pattern, all we need to do is this. It says 0.1%. Well, if I move that decimal 1, 2 over, I'm going to end up with this. Or if I said 0.5%, I move that decimal over 2 places, like that. Now another way to think about this, 5.1%. I have 0 decimal, tenths, 0 hundredths, and then that 0.1% there. Then it says we can also use number lines to show percents between 0 and 1%. Now this is a confusing point. If I just said at the beginning of this lesson, draw me a number line and show me a percent that's between 0% and 1%. That would be a hard ask. But let's see what we can do with that. Here we have the number line, and we've got 100%. And here's 1%. And there's part of 1%. Well, let's instead, we'll do a number line like this. 0%, 1%. I could find a decimal between this. Well, here, how about this? 0.2%. There we go. This example then says we can also extend the pattern of writing percents greater than 100. Well, that goes right back to our pattern of before. If I said write 101% as a decimal, well, percent is a hundredth. So 101 hundredths, move that decimal over. 101 hundredths, or 1.01. All we have to do is take the number and end it in the hundredths place, and you're good to go. Or if I said 110%, move that decimal over 2 places, and you've got 1.1. If I said 150%, oops, move that decimal over 2, you've got that. Then it shows the number line, and it says that you can do that as well. It shows 0%, 100, 200, 110% is just a little more. Now, percents going more than 100 is tricky, because a lot of people say, well, I don't get 110%. There's no such thing as more than 100%. Well, there can be. Let's say that I have $10 to spend. And mom says, oh, you can go to the store and you can spend $10. And then I fill up my arms with all these things I want to buy. And we get up to the cash register. And it costs $11. I spent 110% of my budget. She said I could buy $10, but I overspent it by 1/10. And then mom goes, oh, okay, fine. She pays for it. I spent 110%, so she said, well, I'm going to take a little off your allowance next week. You can have more than 110% in some instances. So for example, I'm working in the store, I'm working overtime, and it's a holiday. On holidays, they hire you for extra. They pay you time and a half. They pay you 150% of your rate. So if you make $10 an hour and it's a holiday, they'll pay you $15 an hour, or 150% of your pay. So that's some examples of how you get more than 100%. All right, let's take a look at a couple of examples. We're going back to representing with those 100 pieces, just like you did in 5.1 last week and had your quiz on. And so it says, write 210% as a decimal. Well, first, let's use that pattern, 210%. And we know that we can just go whack, whack, and move it back. Oops, not starting with 0. We move that decimal 2 places. Well, this is where you're like, yeah, I know how to move the decimal, but why does it work like that? Well, here's a couple ways to look at it. 210% or 210 hundredths. 210 hundredths ending in the hundredths place. Or we could look at it like this. We could say, well, 210%. Well, that's the same as 210 hundredths, or 210 over 100. When I take 210 and divide it by 100, and I can use my calculator for that, it's going to spit out 2.1 or 2.10. Same. Now let's look at it as a chart. Here the chart is, and if you can't quite see this clearly, I'm sure you have your book in front of you. If you're watching this video, I'm sure you're not watching this video because it's just so darn entertaining. But 100% is represented by 100 squares. So I have 1, 2, and 10. 210%. If this was one of those square cut cakes, I've got 1 cake, 2 cake, and 10% of a cake. The cost of winter coat is $80. The selling price of the coat is 230% of the cost price. So what this means, to make the winter coat, it costs $80. Like if I want to make and sell winter coats, it costs $80 for me to make each one. But for me to sell it, I can mark it up to 230% of what it costs, or 2.3 times what I paid to make it. Because stores like to sell stuff at a profit. What is the selling price of the coat? Well, let's first look at 230% as a decimal. 230% as a decimal. I can knock that decimal back a couple, and I'll get this. Another way to look at it is 230%, well, percent is out of 100. 230 hundredths equals 2.3. Well, if it costs me $80 to make a coat, well, that's $80 times 230%. Now I can get my answer. It's $184. Because I took the price of making the coat. I know it's 230% markup. That's what I'm selling the coat for. Now, once again, it shows you in the number line, and you can look at this in your book. It shows that 100% of the price of the coat is $80. And 230% of the coat is $184. And here's the math of how we figured that out. Now, how did we make the number line? Well, we just had a number line that was 0 to 300%. And we knew that 230 would be past the 100, past the 200, and about here. And our math told us that 80 times 2.3, or 230%, equals $184. Example number 3. We're just going to run through this quick. I won't put it on the board because you have your book in front of you. 2004, population of First Nations people on reserves in Alberta was 58,782. About 0.28% of these people belonged to the Mikisew Cree band. And it says how many people belonged to the Mikisew Cree band. You know what? I lied. I'm going to put it on the board. I can't resist. I'm a math nerd. So I've got this many people. And I want to find out what 0.28% of them is. Well, initially, what you're probably going to think is you're going to go, oh, well, I'll just go like this. It won't work quite. Because what you're going to get is going to be a little bit off. I'm going to estimate really quick, and then I'm going to use a calculator to figure it out. So if I estimate, that's like saying this, about a 30% of it, about 30%. So I'm going to get a calculator, and we're going to calculate that together. So if I take, pardon me, I got a broken calculator. Here we go. 58782 times 0.28. Then that tells me that 16,458.96 people are Mikisew Cree. Well, let's estimate. This, as a percent, is less than 1%. Is 16,000 less than 1% of 58,000? No. I think I must have done something wrong. And this is a confusing point for many students. But I realized something. 0.28% is not 0.28. If I take 0.28 as hundredths, because that's 0.28 of 1%, it doesn't really work. I need to have whole numbers. I can't have a decimal there. Well, you know, I could times it by 100. That would give me 28 over 10,000. 28 10,000ths. Well, let's take a look. Tenths, hundredths, thousands. 10,000ths. Wait, 28 ending in the 10,000ths place. Now, I have my decimal. Now let's fix what we were trying to do. So what I wanted was the population times